Okay, guys, thank you for joining. Okay, so yesterday we discussed about the fragmentation. So I hope everyone is clear with the fragmentation, right? And yeah, most of you people have to do the lab, but don't worry, I'll make you to do the lab. So after there is one concept is there. Okay, so after this concept, we'll start taking the lab. And today I'll discuss about the ARP concept, guys. See, guys, how what do you mean by ARP? What do you mean by ARP? ARP.
Say address resolution protocol.
Okay, works in which
Converts
layer?
MAC address. Yeah, it works at data link.
Layer 2. Okay, so what is the use of this ARP?
It converts MAC address.
Converts the MAC address.
Resolves the MAC address.
Yeah. So ARP used to find the MAC address. ARP used to resolve the MAC address with the help of IP address. Okay, so today in our class, we are going to see how the ARP is being resolved with the help of IP address. Okay, see, so we all know that ARP works at layer 2 and ARP is used to find the MAC address. How it is going to find the MAC address? With the help of IP address. Okay, see guys, when it comes to the networking, ARP is the very crucial protocol. Okay, so I would say most of you people have to more focus on this ARP, because if ARP is not doing properly right, then you cannot reach to the end destination. See how TCP is important, how IP is important. More than that, this ARP is very important. So it looks so simple, but you're going to see what is the complexity of the ARP right now. Okay, so we have different types of ARP. We're going to see that one as well. Okay, so first of all, let's take a pure layer 2 or layer 3 switch. Okay, we have two different scenarios, right? ARP in same subnet, ARP in different subnet. Okay, let's see how this ARP will work. So you have a PC1 and you have a PC2. Okay, I'm trying to ping. Okay, so my PC1 IP address is 10.1.1.1 and this is 10.1.1.2. I'm trying to ping from PC1 to PC2. Ping works in which layer, guys? Ping works in which layer?
Layer
Network
Layer 3. Okay, so layer 3. So what is going to be adding in network layer? See
Source
when you try,
IP and destination IP.
correct. So I'm trying to ping. Ping uses which protocol?
ICMP.
ICMP. Okay, so and what will happen at network layer? It's going to add the source IP and destination IP. So what is the source IP?
It be 10.1.1 here.
Yeah, PC1. And what is the destination IP?
10.1.1.
PC2. Okay, so this packet is encapsulated, come down to the layer 2. So what is layer 2 here? Data link layer. Data link layer, what is responsible for adding source MAC and destination MAC? So what is the source MAC? What is the source MAC?
PC1 MAC.
What is the destination MAC?
We have to find out.
We have to find out the destination MAC. See, first of all, you know where to go. See, for example, this is, I'm staying in, I'm from Visakhapatnam. Okay. So, I want to go to Bangalore. Okay. So that is my source and this is my destination. Okay. So Visakhapatnam is just like an IP address and Bangalore is a destination IP. But in Bangalore, where should I go? You got my point? In Bangalore, where should I go? I have to go to Martali. So Martali is like a MAC address. And here I'm staying in a, Murali Nagar. That's a colony. That's is my MAC address. So I know my MAC address. Okay. So I'm staying in Vishakhapatnam. In Vishakhapatnam, where I'm staying in Murali Nagar. So I have to go to Bangalore. In Bangalore, where should I go? I have to go to Martali. Okay. So here, so PC1 is trying to ping. Ping works at which layer? And layer 3 ICMP is going to be used. Source IP and destination IP is added. And the PC, when it comes to the data link layer, it is having the PC1 MAC, it's source MAC, and destination MAC we have to find out. So for finding out the destination MAC, so what PC is going to do, PC is going to check in ARP cache. So if it is a Windows machine, so this is your ARP cache. Okay. So for every IP address, there is a MAC address. See, for every IP address, there will be a MAC address. Okay. So for the destination MAC, what PC is going to do? PC is going to check in its ARP cache. If it is there in the ARP cache, for which IP has to check the MAC address, guys? Can you tell me for which IP the MAC address has to be checked here? For which IP the MAC address has to be checked?
Source IP.
Source
No.
IP.
Why? Why source IP?
Destination.
Correct. Destination IP. So for destination IP for 10.1.1.2, is there any MAC address inside my PC1 ARP cache? What do you mean by cache? Cache is nothing but a storage. Okay. So in my PC, I have to go and check it in the ARP table or ARP cache, whether there is any entry for the MAC address for destination IP. It is going to check. If it is there, then it's going to add the MAC address. If it is not there, then it is going to resolve the MAC address by using ARP protocol. Got it, guys? Yes, no? Yep. Any questions so far? Rachit, Ashwini, Tirmlesh, Abdul, Vamsi?
Yes.
No, sir.
All good? Okay.
Good.
Okay. So now if you look into this, right? Okay. So it's try to, who is going to generate the ARP request? Your PC is going to generate the ARP request. See guys, what and all I'm just telling you, right? This is nothing but your, this creation of L3, L2 headers. This is called as a traffic generation. So who is generating the traffic? Your PC is generating the traffic. Who is initiating the ARP request? Your PC is initiating the ARP request. Why it's initiating the ARP request? To find out the MAC address with the help of IP address. Okay, so we have the IP address for destination IP. For this IP, what is the associated MAC? That is what we're going to find it out now. Okay, now what will happen now? So before, see, PC has to do the ARP request. Before doing the ARP request, your PC is going to check. Okay, your PC is going to check whether the source IP and destination IP are in same subnet or different subnet. Okay, so as being a user, okay, I know I can see the IP address. I can say, okay, both are in same subnet, same network, same subnet or same network. Okay, but how PC will come to know whether both are in a same or a different network? So to find out, PC is going to do the AND operation. How the AND operation will work now? It's going to take the source IP and it's going to take the destination IP and do the AND operation with PC1 subnet mask. Okay, so can you quickly convert 1011 into binary format, guys? Come on. How can you do this converting into binary?
4 zeros,
Mm-hmm.
1010. 7 zeros 1.
How will you write 24? How will you write 24, Abdul? Are you there for submitting class?
No, Satya.
Oh, okay. How will you write 24?
8 ones.
24 once.
24 ones.
24 ones. Remaining zeros.
8 ones.
What is the network address here? What is the network address? How I mean, like, you know, so what is the final output here? Vamsi?
How many output?
4 zeros.
Zero,
1 0 1 0.
zeros, 1 0 1 0. Next 0 0 0.
7 zeros 1.
Last one 1.
7 zeros.
Last one 1.
7 zeros 1. 7
7
zeros.
zeros. 7 zeros. 8 zeros.
Sorry.
Yes.
Okay,
sir.
so what is the address now? 10.1.1.0.
Yes. Sir.
Okay, so if you convert this one as well, same like that, it will come like this. Okay, so this is called as a network address. So the network address matches for, you know, the network address matches. Both are in a, then PC confirms that both are in a same subnet. Okay. Now, once PC confirms both are in a same subnet, now then PC will generate the ARP request or initiate the ARP request. How it is initiating the ARP request? See guys, how we have the IP header and TCP header. So we also have the ARP header. Inside the ARP header, what are the packets will be there? So there will be a sender IP. What is my sender IP, guys? To PC1, 10.1.1. And what is my
10.1.
sender MAC? Sender MAC is PC1 MAC. What is the target IP? Which is PC2.
Standard.
And yeah,
That's
and
one.
target MAC is going to be all zeros. This is what we find it out. Okay.
Yes, sir.
So this is called as a ARP header. Okay. Okay. So this will be this process, right? It will be kept aside. After this, what will happen? It's going to generate the ARP request. Okay. So ARP request has been generated. So this is how your ARP request packet will go. Now this ARP request is a broadcast, right? This ARP request has to go to the switch. How it will go to the switch? Just simply it won't go. Okay. So what is this called, guys? What is this cable called? What is this cable called?
Ethan.
Ethernet cable.
Ethernet
Okay.
cable.
So we also have the Ethernet header. Okay. So the data will not go on the wire. It will go on the wire, but there is a format. So see, again, the data will go, this data, right, will placed in the Ethernet header, and the actual data will go in the 1010 format. We'll show you in the Wireshark capture. Okay. Okay. So now there will be an Ethernet header. I will discuss about Ethernet header later, guys. So just for time being, I'm just letting you to know now. So this is called this Ethernet header, FCS, data portion, and type, source MAC, destination MAC. So what is the data? This ARP data will come here. I mean the sender IP, sender MAC, target IP, target MAC. Okay, what is the type? Which protocol we are initiating? ARP. What is the source MAC? PC1 MAC. So what is the destination MAC? It's going to be broadcast. This is an ARP request, right? This ARP request frame. Okay, so that is what it is. So your PC generated the ARP request. That ARP request put it in the Ethernet header. Now the data will flow on the Ethernet cable with the bits and bytes 1010 like that, and will go to the switch. Now one switch receives this, this ARP request packet, right? Okay, so it will going to see the destination MAC is FFF. So what once switch receives the packet, right? It's going to see the destination MAC. Okay, for the destination MAC, it will do the MAC lookup on the destination MAC. What is the destination MAC is FFF. So whenever you see FFF, right, that is a broadcast. So when broadcast means, so what switch will do? Switch is going to forward that packet to all the ports. So even this, so if you have a lot of devices are connected here, switch will be forwarding to all the ports. So the frame, that Ethernet frame will be received by this PC2. Okay, now PC2 assumes that someone is looking for my information, so that's why PC2 will reply back with the ARP reply. So what will be there inside the ARP reply? There will be a sender IP, which is nothing but PC2 IP, and sender MAC, which is going to be PC2 MAC, and target IP is PC1 IP, and target MAC is PC2 PC1 MAC. So now this data will placed on the Ethernet header. Okay, type is ARP, and source MAC is PC2 MAC, destination MAC is PC1 MAC. So this Ethernet frame will go to the switch. Once switch receives the packet, right, it's going to check the destination MAC. So what is the destination MAC? The switch has to forward to the PC1 MAC. Okay, so switch is going to look into the MAC address table for PC1 MAC on which port it's connected. Let's say it's connected on port 1/1/1/10. So once switch receives the packet, right, it look at the destination MAC table and forward the packet to PC1. Now PC1 receives the MAC address of PC2 and put it and have an entry in this MAC table, and then here it will put the PC2 MAC. Okay, so now we got this piece. This is called as an ICMP request. Okay, so the request will go to the switch and switch will forward to the PC2. Now PC2 will do the ICMP reply. So this is how you're resolving the MAC address, guys. So ARP is used to find out the MAC address with the help of IP address. That is very simple, but there is a lot of process which is going to be happening at the back end. This is what the process. You guys able to understand?
Yes, Satya.
This is in a same subnet. What else if it is a different subnet? Okay, so let's see. Even we'll talk about that one. Same subnet and different subnet. See, I'll take this PC. Okay.
Satya, this cloud uh, cloud system, this IOU1, I can't find in my GNS3.
Yeah, that has to be imaged.
Yeah.
That that there is a separate image. I gave you the GNS3 images, right? That is an L2 image. Okay, so whatever the default L2 image you have, right, that will not open the console. Okay, you can also put this, but you cannot open this one. So if you want to see anything, right, you have to use this one. The image is already shared to you. Once I gave you the email, right, GNS3 images. Once you click on it, right, there will be IO02 images. When you click on it, right, this image will come, IO01 or IO02 images.
Okay.
See, we have PC2 and PC4 will be in the same subnet. Okay, now let's see how MAC address is being resolving it. Carefully listen, guys. Why it's reconnected? Just give me 2 minutes. This is a small lab only. So first let me configure the IP address on R1 F0 by 0. I'll go to config mode, interface, fast ethernet, F0 by 0, IP address 10.1.1.100. Okay, I just gave this IP address. And now 1 by 0, F1 by 0. I'll give this is a different range. 1.100. Okay. Okay. This is /100. Okay. Now let me configure the IP address on this one. So you carefully observe this, guys. Very, very important. Okay. I run the Wireshark captures on PC1 and PC2. Okay. Wireshark captures are being running or not? Okay. It's opening. Okay. This is PC2. Okay. This one we got it. And we need one more capture, right? Okay. PC2 and PC1. Now we should give the IP address. And we shall also give the gateway. Okay. 10.1.1.100. That is a gateway. Okay. See, this I'll discuss this later, guys. What is happening at the back end? This is very, very important. So this gracious ARP is very, very important. I'll discuss this later. When we talk about different types of ARP, I'm talking about normal ARP. We have three more different types of ARP. That is reverse ARP, proxy ARP, and gracious ARP. Gracious ARP is very, very important. Okay, now I've assigned the IP address on my PC1. Now I will assign the IP address on PC2 10.1.1.2. Okay, 255.255.255.0. And what is my gateway? Dot 1.100. Okay. So if you look into this, right? So this, so PC1, this one. This is PC2. So it keeps, as soon as you enter the IP address, right? It's sending the gracious app. Why it is sending it? We'll discuss about when we talk about the gracious ARP concept. Okay. See guys. Now I will try to ping from PC1 to PC2. Okay. Let's see what is happening now. Even I'll also open the switch. So this is my switch, right? So switch is going to read the MAC address. So if I see show MAC address table, so see on 0 by 0, okay, 0 by 0, this is the MAC address, PC1 MAC address. Okay. Okay, this is the MAC address of PC1. Now let's see for PC2. 0 by 1. Okay, this is the MAC address of PC2. Okay. All right, guys, this is the IP, this is the MAC. Now I'm going to check, I'm going to ping from PC1 to PC2. Since it's a, no, I don't, I can see it's a virtual PC. I cannot look into the ARP table and all. That is not possible. I think, let's see, ARP iOS. Okay, so I think I cannot check. Okay, see, ARP table is empty. This is the command. Okay, you have to type ARP table is empty. Even if you look into this, guys, are you following, right? Everyone?
Yes, Satya.
Ashwini, Tirumalesh, Megla,
Yes, Satya.
Rachit.
Satya.
Yes, sir.
So
Yes.
now you see this one. Now this is my PC, right? I'm going to ping from PC1 to PC2. Let's see what will happen. Ping 10.1.1.2. It will ping or not? It will ping or not, guys? It will ping.
Ping.
See, I'm getting the response. Okay, so let's look at this captures. So, okay. Okay. See, when you try to ping, what will happen, guys? When you try to ping, what will happen? Abdul?
Connection will be established.
How connection will be established, man? When you
I
try
mean-
to ping, what will
I see
happen?
it come-
Reply
It
will
will say connectivity of other end.
See, when you try to ping, what will happen? See this one. 10.1.1 is my IP address, right? See, what is doing this? ICMP ping request is being generated. See, this is very, very important, guys. Just be focused. When you try to ping, what will happen? ICMP request is being generated. At which layer?
Layer 3.
Layer
Layer
3. And layer 3 is responsible to add the source IP and destination IP. Correct? Yes or no?
Yes.
Yes, sir.
Now come down to the layer 2. Correct? Layer
Yes.
2 is responsible for adding the source MAC and destination MAC. What is the source MAC? PC1 MAC.
PC1.
So
PC1.
6800. See, 6800.
Yes.
Okay. So PC1, how we got the destination MAC? So it is doing the what? How we got this destination MAC, guys? How we got the Abdul, you there?
Yeah, Satya, yeah.
Yeah. How we got this destination MAC here? How we got the destination MAC? Through ARP process. See, See, your PC is sending the ARP request. Who has the MAC address for 10.1.1.2? See, ARP request. This is a broadcast. So, okay. So your PC created the headers like L3 header, L2 header. In L2 header, there will be a source MAC and destination MAC. For finding the destination MAC, so what PC did, PC sent the ARP request. See, this is your ARP request packet. If I open this ARP request packet, right? See, there will be a sender MAC address, sender IP, target MAC address, target IP. Okay, so this is how you have to follow, guys. This is how you have to learn. Okay, so sender MAC, okay, sender MAC is the PC1 MAC, sender IP is 10.1.1.1, target MAC, since we have to find out, right? This is the ARP request, this is a broadcast, so it's a broadcast. Target IP is 10.1.1.1.2. So this ARP request will put it in the Ethernet header. Okay, so in the Ethernet header, as I told you, right? So this one, FCS. Okay, see, FCS, frame check sequence number, and you have the ARP data, and you have the type. So what is the type? ARP 0x806, this is the code. And you have the source MAC, PC1 MAC 6800, and destination MAC is FFFF. Okay, so this entire request, the request will go to the switch, and switch will broadcast to this guy and this guy. Okay, now PC2 will reply back. So 10.1.1.2 is replying. If you see this one, right? See, sender MAC. This is 6801. This is PC2 MAC. Okay. So, and sender IP, which is 10.1.1.2 PC2 IP. Target MAC, which is the PC1 MAC. Target IP, which is the PC1 IP. This data will put it in the Ethernet header, and then from Ethernet header, it will go to the switch. Once switch receives the packet, right? It will look into the destination MAC address table. See, the switch is being received from the packet from this interface. From 0 by 1, it is receiving the frame. So it's going to look at the destination MAC. So what is the destination MAC here? We have target MAC is 6800. So where is the 6800 is connected? On Ethernet 0 by 0. So once the packet is coming, it is destined for this 6800. So switch is going to look 6800 MAC address is listed on which port? It is listed on Ethernet 0 by 0. So then it will be forwarded to PC1. Got it, guys? I have the documentation. I'll give it to you. Don't worry. So this is very, very important. So if you know this one, packet flow is what this is called, this packet flow, guys. This is called the packet flow. And if you explain the ARP concept, 50% of your interview is done. I mean, to the companies which I'm referring, like CSS Corp, Fat Pipe, or Infoblox, okay, or Dell. So these are companies, they'll concept on ARP. If you know the ARP, and everything is good. So guys, you're able to understand this or not? Rachit?
Yes, Satya.
Okay, so tomorrow I'm just thinking whether do we need a lab or we'll go with an exam. Tell me. Tell me, guys. Huh?
Lab. Shall we go with lab?
Okay. Then Sunday will be the exam.
Okay, sir.
Okay.
Satya.
So tomorrow we'll do the fragmentation lab, IP here, trace route lab, and then this ARP lab. Okay, ARP in the same subnet. And we also have ARP in the different subnet, guys. See, different subnet. Now let's see now. I have the router one, right? I have the PC3. What is my PC3 IP? 192.168.1.1. What is my gateway? Okay, so let's talk about now. Let's talk about the ARP in a different subnet. So the same PC1. Okay, see now let's go to the PC1. So let's see ARP. Oh, ARP table still is empty. Yeah. Okay, fine. Fine. So I'll try to ping from PC1 to PC3. Let's see whether I can ping or not. I'll go to PC1. I'll try to ping 192.168.1.1. Okay, let's see whether I'll get the reply or not. I'm getting the reply. Okay, so I try to ping from PC1 to PC3. Okay, so what will happen, right? When I try to ping, what will happen? Abdul? Abdul,
Yeah, Satya.
when I try to ping, what will happen? Megla? Megla?
It will send the ICMP request.
Okay, ICMP request will be generating it. At which layer? See, you're able to understand what I'm trying to say? Or it's just like a nightmare, or you're finding some difficulties in understanding it.
No, Satya, we can understand.
Okay, so then yeah, I've repeated so many times, right? So
Yeah.
when you try to ping from PC1 to PC3, what will happen?
It will
ICMP ping will come into picture and the header will be created.
Yeah,
ICMP.
so yeah,
Yeah.
which header will be created? Which header will be created?
L3,
ARP header.
Why ARP header will be created?
L3 and the L2
In
header will
L3
be
header, ICMP ping request will be get added, and then it's going to add the
IP,
source IP and destination IP.
destination IP.
So what is the
L2
source IP? What is the source IP?
PC1 or PC1?
Okay, what is the destination IP?
PC3, you're
PC2.
pinging
Oh, sorry.
PC3, right?
Yeah, PC3.
PC3 will be the source destination IP address and the source IP will be the PC1 IP address.
What is the source MAC and destination MAC?
It's a PC1 MAC address and
Destination MAC?
the PC2's MAC address.
Destination MAC.
Sorry,
We
should get it.
PC3
destination back.
PC3.
So this is the one mistake. Okay, so yeah, I'm fine because you're not aware of it. The destination MAC. See, first of all, okay, so there is no entry. So tell me the flow, guys. When you try to ping, what will happen? What will happen when you try to ping?
We'll send the
When
ICMP
we will-
request.
Request will go, right?
Yeah.
After that, it's going to add the source MAC and destination MAC, right?
Right.
Yes, right.
Yes, yes or no?
Yes.
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 Source IP, destination IP will get it. And after that, it will come down to which layer?
Layer 2.
Layer 2, what will happen?
ARP.
Source MAC, destination MAC.
Don't say the ARP here. First of all, it's going to see there is a header creation will happen. After header creation, right? So it's going to put it all the fields. So in layer 2,
Source
first it's going to add the source MAC and destination MAC. Source MAC
Okay.
is PC1 MAC. And what is the destination MAC?
Yeah,
PC3.
PC3.
That's the stupid answer.
We
FF.
have
That's the stupid answer. So come in a flow. So what will happen at, when you try to find out the destination MAC?
ARP MAC will be added so that it can be sent and then
No. What did I told?
Destination MAC, we don't know. No, that's why FF.
It will check in its ARP cache
Correct.
whether the destination
It's
MAC
going
is
to check
present.
in the ARP cache.
Ah,
So,
okay.
so what it's going to check in an ARP cache?
Whether
Destination
the
MAC.
destination are
Okay. If it is not listed, then what will happen?
broadcast message will be sent.
Don't give the stupid answers. So tell me in a flow. So if the destination MAC is not listed, what will happen? If the destination MAC is not listed, what will happen?
It's check whether the both source IP and destination IP are in the same network or different network
Correct. So how it's going to check?
by performing the AND operation.
Now, can you tell me both are in the same or different subnet?
Different
Yeah.
subnet.
If it is a different subnet, okay. So the broadcast, right? See, if it is a different subnet, right? See, first of all, the routers will not propagate the broadcast. See, that is why the first class, which I've told you, right? Basics of networking. So the broadcast, right? The switches will, the switches used to forward the broadcast, but the routers will not forward the broadcast. So if the switch is sending the broadcast, right? So it will stop here only. Okay, it won't go here. So if the PC1 is sending the ARP request, right? ARP request. ARP request is a broadcast. So guys, do you know what do you mean by broadcast? Everyone? Okay, tomorrow your question is like, what is broadcast domain and what is collision domain? Please make a note of it. Very, very important. These are all the basics. Okay. So when PC1 is sending the ARP request, right, to find out the destination MAC of PC3, it cannot do that. It is not even possible because ARP request is a broadcast. The request will go and routers will not forward that broadcast to the other network. That is will not happen. Then which MAC address will be there here? Which MAC address is going to get added? In L2 header, we have a source MAC is PC1 MAC. So what is the destination MAC? What is the destination MAC? If it is a different subnet, it's going to be the gateway's MAC. It is going to be the gateway MAC. So if you want to see, yeah, you will see that in the Wireshark capture. See, I'm trying to ping. See, ICMP ping request has been generated at layer 3. Layer 3 is responsible to add the source IP and destination IP. And at layer 2, right, there is a source MAC, and the source MAC is 6800 is the which MAC address? 6800 is this which MAC address? Which MAC address? PC1 MAC address. And destination MAC, see, 8C000. 0x2 interface it's connected on. 0x2 interface. Okay, R1 router 1, this interface MAC address is 8C40. Okay, so your PC see, that is what the MAC address has been added. But before that, it sends the ARP request. Before sending the ARP request, it tried to find out whether both are in a same or different subnet. So by doing the AND operation, it came to know both are in two different subnet. So PC generated the ARP request. If you see the ARP request, right? If you see the ARP request, so your PC is sending the ARP request to whom? To whom? Which IP address is this one? Which IP address? See, sender MAC is the PC1 MAC. Sender IP is a PC1 IP. Sender MAC is target MAC is broadcast. What is the target IP? What is the target IP, Abdul?
Router IP.
Router IP. So when it is a different subnet, your PC is going to generate the ARP request for gateway's MAC address. Okay, and we'll get the reply from the router, and then it's gonna add it. So it's gonna add the destination MAC address as gateway's MAC, and then ICMP request will go, and then we'll get the ICMP reply. Okay.
Okay, sir.
Okay. Any questions on this one? Any questions? I'll give you the document, guys. Please go through it and also try to do the lab. Okay. This is very, very important.
Okay, sir.
Okay. So yeah, so these things, guys. So before we getting into routing or switching or security, right? No matter whatever it is, till now, your TCP, your IP. See, if you want to get into security, right, you have to know about TCP. If you want to getting the routing or switching, right, you have to know IP header, you have to know ARP header. So it's going to be a link. So you will come to know when we're talking about switching, right, how these basics are going to be really, really helpful. Because whenever you get into, see, networking is a one domain, in that you have multiple subdomains, like routing is one, switching is one, and security is one. You have load balancer, whatever it is. Okay, you have from layer 3 layer 2 to layer 7. I mean, in terms of voice, layer 2, layer 3, you'll be having working on L2, L3 switches, or in layer 3, you'll be purely working on routing. And layer 7 means, see, and layer 3 firewalls also will be there. Okay, so the Palo Alto firewalls will start from layer 4 to layer 7. All the firewalls will start from layer 4 to layer 7. Okay, so see, if you want to work on security, right, you should know about TCP. If you want to work at layer 2, layer 3 stuff like routing or switching, you have to know these IP header and ARP header. Okay, so that is why I'm focusing on this. So once we are done with this thing, then only we can switch to the switching part. If you're not clear that, you won't understand switching part. See, you have to understand the packet flow. So that is why I'm discussing all these concepts. Okay, so just focus on this. Tomorrow we'll doing the all the labs. So I just want you to make sure, see, this is the topology, guys, for the ARP in same subnet and ARP in different subnet. So we'll do it on one lab. Okay, so instead what you can do, you can add one more router, R1 and R2. Connect R1 to R2, R2 to I0, IO2, or you can just put a normal switch, that is fine. So tomorrow when you come, right, at least do this one, who are all GNS3. This is R1 and R2. Okay, switch PC1. This is a switch. You can connect multiple pieces here. Okay, so we have R1 and we have R2. Okay, so this is the lab. So try to configure at least. So Ashwini, Rachit, you have your GNS, right? So do this one. Okay, at least before doing the actual lab, just configure the IP address. Just configure the IP address. If you want the IP address, right, I can give like between R1 to R2, you can put 1.1.1.1 and 1.1.1.2. Okay, and this interface IP address is 10.1.1.100, and this interface IP address is 192.168.1.100. This is 10.1.1.2 or 10.1.1.1, 10.1.1.2. This is 192.168.1.1, 192.168.1.2. Just draw this diagram and assign the IP addresses. I think everyone knows how to assign the IP addresses, right, Vamsi?
Yes, sir. Yeah, I know, sir.
Okay, so do this thing. So we'll see most of the scenarios. We'll complete tomorrow all the labs, even the TCP also we're going to do it. So we can refresh the TCP just by configuring the SSH. That's all. So within one diagram, you can do everything. Okay.
Perfect.
And tomorrow I'll prepare the lab document once we are doing it right. So we'll start working together tomorrow. Come at 9:30. It'll take little long hours because we are doing the lab, right? So even I'll try in front of you, I'll prepare the lab document and everyone has to do it. So the people who don't have the GNS, at least try to do it on the packet tracer. Okay. All right, guys. Any
Okay.
questions?
No, sir.
No, sir.
No,
Okay,
Satya.
then. So tomorrow we'll meet up. Okay.
Okay.
Bye-bye.
Thank you. Sir.